So I've mentioned before that, it's common that you need to do some preparation to your data before you perform your different analysis. And this can include the evaluation of outliers. But until now, we've not spoken about how to identify outliers or how outliers affect the linear regression model. So the purpose of this specific lecture is to look at identifying your outliers, how to do this in SPSS, and what to do with an observation that's been identified as an outlier. So at this point in our data mining process, we've already done some modeling, and now we're looking at how well things fit. So this may mean that we now have a better business understanding that is going to result in us having an idea of how to approach the problem maybe differently, which may perhaps lead to some additional data preparation before I make my model. So even if we make all of the assumptions of multiple linear regression, it's still possible for our slope estimates to be biased. So for example, when I have cases with extreme values that are quite different from the rest of the sample, we can see some shifts in the central tendency and the dispersion as a result of these influential observations. So these values can end up in your data set for a variety of reasons, including data entry errors, cases that are highly unusual may warrant a separate set of analyses, or sometimes they're even part of a bigger trend in the population as a whole that just wasn't evident in your sample that you have. So even if you have one outlier, especially if it's really different from the rest of the sample, can make huge changes in the values that are estimated, especially when we have a very small sample size. So here we have red points that represent our data in this sample, and here we have our best fit line to describe the data set. Okay, so we notice we have this extreme point over here that's kind of pulling our regression line up. But if we were to draw a new regression line ignoring that extreme point, we now see that the resulting line is much closer to what the rest of the data points are doing. And so there's many approaches that you can take when you're identifying your outliers in your data. One of the easiest ones is to make a scatter plot like the ones we saw on our previous slide to visually identify those outliers. Another strategy is to use one of the many diagnostic statistics that we have, such as Cook's D, which is a distance, or DF beta. We can look at our residuals, or we can look at our standardized residuals. So if we're trying to do this in SPSS, when you're getting your regression model, you're going to click on the Save button. And that's going to be on the right-hand side of that regression model setup. So when you're picking what your X and your Y variables are off to the right, you should have a Save button. And when you do this, you see something like this window that pops up. And this is where you can select a variety of values that you can have calculated and saved for each observation. Some of the things that, if you're looking at outliers specifically, you can request in the unstandardized or standardized residuals, the Cook's D, the DF fits. And with all of these diagnostics, really the larger the value is, that's going to indicate that the case is more likely to be an outlier. And so this can be very useful when you have a very large data set. Here we have a scatter plot where we're looking at reading test scores versus the average number of hours spent studying each day. So after we prepare the scatter plot of the data, we see that the case 7 is visually separated from the rest of the data points. And it would be very likely that this value right here is going to be an influential data point when we prepare our regression model. So if we were to take this data set and run a regression analysis in SPSS, this is what part of your output would look like. And so here we see that the beta for hours studying is not statistically significant at the 0.05 level. What we see is that we have our beta of hours studying as 3.081 divided by my standard error of 2.617 gives me a t-value of 1.177 with a p-value of 0.292. So that's greater than our 0.05 level, which is what is pretty standard for using statistical significance. So we see that that's not statistically significant. We also see from our R-squared statistic that that value is 0.217. And what that means is that the variance in the amount of time spent studying only really explains 21.7% of the variance in the reading scores. And so some different kind of assessments or tests that you can do on your outliers, they kind of take a more objective approach to identifying your outliers. So first we have residuals and standardized residuals. Your residuals are going to be the difference between your predicted value by the model and the value that you actually observe. A standardized residual is going to put all of your values in terms of standard units or standard deviations so that you can compare your results from one model to another model more effectively. And it's really common to look at the residuals as those standardized values that are greater than 3 or less than -3 to be considered outliers. But as with many things, this is up to your judgment, and there are several rules that use different cutoff values. Another diagnostic that we've mentioned already is Cook's D, or Cook's distance. What it does is it measures the distance between the observations that you have and the predicted values, so that you can identify the points that are strongly influencing the estimates of your regression model. So if we were to have saved the residual, standard residual, and Cook's D to our data, these would be the values that we would see in our data view portion of SPSS. And so if we remove that one observation and run our analysis again, we see that the p-value from that t-test of our slope is 0.014, which is statistically significant at the 0.05 level. We can also see from the r-squared, the variance in the hours spent studying now explains 81.6% of the variance in the reading scores. So clearly this model fits the data much better now without that one observation. And so this leaves us with the question of what to do with our outliers, right? What do you do to determine the nature of the observations in question, right? Obviously, you don't want to just throw out your observations that don't fit your intended modeling type. That has some integrity issues, right? But when you remove outliers, you're destroying data. So clearly, you don't want to destroy data unless you have to. But you also need to disregard cases that have obvious entry errors, such as, if an observation is coded with a value that's not eligible for that variable. So for example, if you have a variable that's coded 1, 2, 3, or 4, and you have a value of b for that variable, that would be very apparent that this was a coding issue and you should drop that case. But remember, when you're removing cases, you're still destroying data. So one of the things that you can do when you're running into problems with a model is to always collect more data. So you want to be really judicious about when you're deciding to throw out cases. When's it good to drop the cases? You're going to want to drop your cases from your analysis if they're obviously entered incorrectly, as I mentioned before. If they're so extreme that they're influential on the model, so you can actually see it pulling your regression line. Or, if there's a justification for dropping that observation, such as that observation not being part of the data set that is actually included in your sample. So, for example, you may have identified the population being studied as first-generation college students, and you sample a bunch of students, and then you find that perhaps you have a second or third generation college student in your sample set. So since that's not part of the population that you're studying, you need to remove that observation. If you have a group of observations, especially if you have several of them, this could be indicative that you might need to look into your data a little bit more to see if there's some other groupings that you might not have considered in your initial phases of your project. And so if you're not sure what you want to do with your outliers, what I recommend you do is that you run the model with everything in there, and then take the observations out and run the model again, and then look at how your final model, how the models compare to each other.